совместно с вами замечательных кафедр нашего университета, в частности, прикладной компьютерной оптики, если говорить о нашем факультете, а также две кафедры инженерно-физического факультета. Посвященный Гдпм Николаевич у нас присутствует. Мы выполняем комплексный мир, который выполняется в рамках такого международного сотрудничества. Ну и в рамках этого сотрудничества у нас уже приезжал и выступал профессор Томас Зегер из Германии. Значит, он еще раз приедет к нам в октябре месяце, потому что будет научная конференция, посвященная сенсорике. Вот. Почему сенсорика? Речь идет о том, что в рамках этой комплексной меры мы создаем основы для создания сложной системы для контроля сложных инженерных сооружений, сложных объектов. И подразумевается, что кроме того, что создаются отдельные датчики, датчики перемещений, датчики напряжений, датчики тепловых потоков, которые характеризуют этот объект. Весь этот комплекс датчиков должен быть объединен в сенсорную сеть, которая позволит создать полноценную картину того или иного сложного объекта, потенциально опасного для сложных эксплуатаций. Ну, о том, какие бывают катастрофы, я сейчас даже не буду перечислять, все сказано. Такие вещи встречаются достаточно часто. Ну и чтобы заканчивать вот эту вводную часть, и вот в рамках всего этого взаимодействия мы пригласили к сотрудничеству профессора Родригеса. Он из Португалии, он специалист по сенсорным сетям, и он сегодня проведет у нас сначала лекцию, потом семинар, но это будет такое формальную границу между тем и другими мероприятиями будет сложно провести, но во всяком случае начнется, наверное, с монолога, а продолжится это движение возможного обсуждения. Ну а для студентов тоже еще немножко скажу. Дело в том, что надо иметь в виду такую вещь, что вот сейчас вы бакалавриат, наверное, будете заканчивать примерно в том же режиме. Мы планируем то, что у нас появится, кроме наших руководителей, магистерских, в первую очередь, и кандидатских диссертаций. Кроме этого, появятся специалисты из других стран, с которыми мы должны сохранить совместное руководство, с одной стороны наше, и подготовка с другой стороны зарубежной. Ну, понятно, что в этом случае, чтобы работа была на достаточно хорошем уровне. Ну вот, это основные базовые представления, чтобы было понятно, для чего все это затевается. Ну а сейчас оставляю слово.
Thank you so much. So good morning to everybody. Unfortunately, I cannot speak Russian. I don't know, sorry for that. I will do my best that you may understand me. And if something is not easy to understand for you, please let me know, raise your hand. I will do my best to explain in other words. And feel free to interrupt me when is needed. So first of all, I'd like to thank Professor Valerie and Victor for inviting me to be here. It's my great pleasure to have this kind of opportunity to cooperation among our universities, and of course it's my great honor to be here and be member also of ITMO. So I will start briefly introduce myself and our research group. So we are working on communications and multimedia. So I share with you some highlights regarding several projects that we've already performed or are ongoing now. And after, I will present a lecture. I hope it may be interesting for you about wireless sensor networks and applications of sensors that you can have now in our world. So, I don't know what Victor and Valerie told about me because I didn't understand. But okay, maybe he mentioned that I'm professor at the University of Interior, and we also have a national research lab called Institute of Telecommunications, so I'm a member of this research institute and leading the group that I mentioned before. So personally, currently I have several international involvements in terms of IEEE. I believe that you know very well this big organization of engineering, and I'm also working a lot on health issues. So currently I'm the IEEE Technical Committee Chair on health, and I'm also working in several issues regarding multimedia, such as this book series we did in the USA regarding multimedia systems and applications. So in terms of journal services, now I'm leading 3 international journals. One of them is edited in Korea by Korean Multimedia Society, and the other 2 are published in the United States. And of course, I'm working in several journals that are very well known in terms of research community regarding the communications and this kind of issues. So our group, we start formally our group in 2007, so about 6 years ago. So we are quite active. I have a lot of students like yours, young people working hard and very interested in new issues. And we have several contributions that you already published in the literature. So we also received several awards recognizing our work. And I'm also pleased to share with you that my last Best Paper Award, just last month, has the affiliation of ITMO. So we published in ChinaCon a paper that received this award, and I'm pleased to share with you that this award also is achieved by ITMO. So in terms of research topics that we're already working, as I mentioned you, so we have lots of work mainly in 3 key research topics. One of them is sensors, applied for body or regular wireless sensor networks. Vehicular communication, this is a name of a technology that we created from scratch, gathering contributions for other available technologies. We patented it and we developed a lot of work on it. I will share with you later some highlights about this project and worked on e-health issues. So in terms of, you know, for us professors and researchers, it's important to get involved in scientific events, not only in journals and in conferences. Now I'm leading the organization of several international conferences, mainly from IEEE and other important conferences I can share with you. For us, in terms of e-health, one of the highest and most important conferences, HealthCom. In terms of communications is GloveCom and ICC, so the 2 major conferences from IEEE Communication Society. So from our group, as I mentioned you before, these are the 5 main research topics that we are working on. And as I already suggested to Valerie, in our cooperation, so we can enlarge the topics covered by his lab, and we can also cooperate in enlarging the research topics, taking account the interests of people on these issues. So on sensor networks, and I will talk about it later in the presentation, so we are working mainly on these topics. This will propose this architecture, and in terms of research project, in terms of also research methodologies, I would like to highlight an important issue for you students regarding research methodologies, because we use several important research methodologies following the literature in terms of research work. So we start to propose the architecture. First work were based on simulation in order to demonstrate that this architecture was feasible and perform several studies through simulation. In the next step, we created a laboratory prototype based on robotic Lego Mindstorms. You know it, I think. So for students it's interesting because they can play with Lego and at the same time working very hard. So we created this laboratory test bed to demonstrate that this technology is feasible and works, and perform several performance studies in terms of evaluating the proposal. And in the last step, we created a real prototype in cooperation with Fiat manufacturer in Brazil, so we deployed in real cars. And I also have a small video to show you just how it works. So in terms of e-health, we have several works ongoing. In terms of mobile communication, the same. And recently, 2 years ago, we started studying mobile and cloud computing, taking into account two main issues. One of them is the opportunity to work in a new and very interesting and promising research topic, and at the same time we take the advantage of Portugal Telecom, our main telecom operator, installed in the city where I live and where we have the university, Covilhã, one of the biggest data centers in the world. So I will also show you several pictures about it. So taking into account this opportunity, the university signed a cooperation contract with Portugal Telecom, and we will create next year an international competency center on cloud computing. So this is also an important opportunity for research and cooperation with the industry. So in terms of cooperation, of course, as we know, or maybe we think about it, we cannot do nothing alone. So all the work that we should do, we can improve it and we can take advantage of cooperation. So we have cooperation in our country. So these are the partners of our university. This is the university, this is health science faculty, several partners and other Portuguese universities and also research institutes. We have also a close cooperation with the industry. This is industry, Portuguese industry, so it's Portugal Telecom, this is Microsoft Portugal, this is a trademark from PT. This is groups, this is a very interesting Portuguese group that is working now in more than 80 countries around the world. This is our university hospital. And this is a startup, a company created by one of my PhD students, so it's nice that inside our lab the people also create new ideas and promote new business. In terms of international issues, in fact, I'm very pleased to share with you a list of universities that we are cooperating. So I'm pleased to put your university in first place. We have PhD students from Dakar, from Canada, and we have research projects ongoing with different universities around the world. So I will be very happy that cooperation with your university, my involvement with you may be increased, of course. In terms of international cooperation with companies, so we have this work with Fiat in Brazil, and we have also a close cooperation with this Italian company. This is interesting because one of the founders of this Italian company is my PhD student. For this reason, he joined us, he came from Italy to join us, and it's really interesting that we can have this close cooperation, of course, because this person is also several times in our lab. So this is a list of several European projects that we are involved. So in the next slide, I'll just share with you several highlights, just to show you different kind of projects that we are working, and just to share with you different kind of research work that we can be done. So in terms of e-health, we have a very big project in Portugal on ambient-assisted living. So the idea is promoting technology for elderly people, and we are leading all the tasks related with mobility issues, and also I'm leading personally the dissemination activity. So as you can see here, the leader of the project is Microsoft. We have about 34 partners, 7 universities and different companies. This is a telco operator, this is another telco operator. You know maybe from Norfolk, from Germany, they have a delegation in Portugal, so it's also a partner and important companies, and these are universities. So this is an interesting project that will finish next year. Funny else, we also merge mobile and ubiquitous computing with health applications, so we create several solutions. This is a project from Portugal Telecom that we cooperate with Beira. This is another project funded by Portugal Telecom in order to detect falls. Mainly this is important for elderly people and promote the algorithms to automatically filter false positive, false negative, and so on. It's a solution that is is an interesting approach that you are using also for elderly people. So we created a solution for emergency situations. Imagine several cars from policy, from firemen working together in an operation theater. So we can provide a mobile device for each car, for instance, or people. We can know on real time where all the people involved on this operation theater is. It's geographically located, and we can provide communication technologies, and at the same time policies and this kind of authorities can follow what's happening in real time. And this is also supported by Portugal Telecom. In terms of wireless sensor networks, I have two PhD students that already concluded his PhD on this topic. There are more two that is in the last part of the work, and several master students. So this is topics that we already addressed related with the wireless sensor network. So we already produced several contributions on this topic. For instance, we created a gateway for wireless sensor networks. And 1 month ago, I received a contact from Intel, and maybe they are interested to discuss with us what we did and what can be done together. So let's see. We already had several meetings through Skype, and they exchanged several messages. Let's see if it's a good opportunity for cooperation with the industry or not. So later I will show you the lecture, so I can go further. In terms of mobile applications, we usually develop for the main for mobile operating systems. Of course, Symbian now is in the last period of its life, but currently we have Android, iOS, and Windows. Microsoft is, maybe you know that they bought part of Nokia, and they are investing also a lot on its operating system. So currently, mainly we are working on Android, iOS, and Windows. So this project for vehicular communication, as I mentioned you before, this is our simulator, the Gdpm Simulator. This simulator, we didn't create it from scratch. As you know, if you already have available solutions for working, we don't need to create from scratch. There are friends here from Finland that created the one operating simulator. Our friend, led by Jörg Watt, they offered the simulators to the web for free, the one simulator, and we worked with it and deploy our architecture on the simulator and develop this model that we have to the core of the real simulator, and we called it Gdpm. We also helped these colleagues to improve their simulator in terms of correcting bugs and improving several approaches. These are inside our lab. These photos of our prototype. You can see these lines simulate roads. You have here crossroads, mobile nodes, fixed nodes. So we'll see later. Next slide, I have a short video just to, I think it's easy to show how it works. And here is the deploy of our technology in Fiat that we performed in Brazil. So this is a photo of the test bed. I don't know if I can show you very fast a video where we can show briefly this prototype. Of course, this is only one highlight. As you can see here, this is a summary of the presentation, and this is nice because we can see how it happens. And before the real prototype, it was really important to show that it works. For instance, one of the main characteristics of this technology is the out-of-band signaling. So we are using control plane to set up the connection and make resources reservation, and you are using data plane for data exchange among nodes. And here we perform these real experiments using Bluetooth for control plane and Wi-Fi for data plane. So in fact, this test bed uses these netbooks because in the previous version we used mobile phones, mobile devices, smartphones, but as you are using at the same time Wi-Fi and Bluetooth, sometimes during the experiment the hardware stopped working, so we needed to restart again the study. So you can see in real time what's happening. There are several signs that show us what happened in real time, and you can easily follow on each experiments. At the end, we can collect statistics to evaluate and also study the results. So it's very easy to configure. We have lots of possible combinations to set up the network and to prepare experiments. So this is in summary what we can do with this. So as I already mentioned, you can easily configure all the issues regarding the different algorithms that you can use, different policies, and also different capacity of buffer on each node, etc. Protocol, etc. So it's very easy to configure. And when you have new studies, we can add it to the available solution. So let's see if we can go further. Just to show here some information about the reports. You can also study the energy consumption, etc. And you can follow, as I mentioned, in real time what's happening on each node. So most recent work on this issue is a real prototype that we created at Fiat. In this video we can see two applications. One of them is a service of warning messages. Imagine that we have a damaged car in a given road, and the system automatically can send a message to a rescue service, for instance, with the location of the car and some notes about what's happening with the car. And another, as you can see here, is the campus of the Fiat. We work there more than 15,000 employees, so it is such as a small city, so it is helpful to make these experiments. Here you can see the hardware, so this is the GPS receptor and the omnidirection antenna. We bought a biggest antenna in order to have more coverage. So we prepare the cars. Here you can see this screen tries to emulate the common onboard computer that we can have in a given car, and we put our embedded computer in the backside of the car. So this emulates a relay node that we can deploy. This emulates a fixed node that acts at the origin and destination node. So this warning message service tries to imagine this damaged car. This is the location of the car, and you can forward it to a predetermined rescue service, for instance. So this is an image of real experiments, and the traffic jam information is very easy. So we deployed in the system an API such as TomTom, so we can provide geographic information. Imagine this car is in a traffic jam queue, and it can inform other cars to avoid this street because you may have the delay. So it's easy to deploy to the other cars, and they can follow a different way. So as I mentioned you, we are also start work on mobile and cloud computing. As you can see here in this figure, tries to illustrate this combination together with mobile combination and covers and fixed mobile, lots of devices, different applications, and ubiquitous utility. So we don't know how technology works, but we are using it. A good example of that is, for instance, Dropbox, Gmail, and this kind of application that we don't know where the messages are saved, where your files are saved, and so on. So as I mentioned you, this is a photo of the data center from Portugal Telecom that I mentioned you before. In terms of area, you can imagine about 10 football fields. This is the map of Portugal. This is the capital, Lisbon. This is Covilhã, where I'm living, where is the city. It's about 2 hours and a quarter far from driving in highway. So here is and just close 1 hour far from Spain. And here is Oporto, the second biggest city. So as you can see here, Portugal Telecom choose our place because of several advantages. One of them is proximity with the university, close to Spain. There are no earthquake perspectives in terms of the soil, and they found their good conditions for that. So in terms of cloud computing, and as we already worked on mobile, of course, you can merge this approach. So in terms of the motivation for using cloud, it is the self-service, ubiquitous access, as I mentioned before, and also the flexible capacity. We can identify 4 types of cloud: the public, the private, the hybrid cloud, and also the community cloud organized by imagined communities of interest. And of course, over cloud, we can connect everything, and everything can run over cloud. In terms of services, so we can have software as a service. An example of that, you can see here someone. So we can access applications through various clients, including browsers, ubiquitously. In terms of platform as a service, maybe you know very well Windows Azure. I don't know if you are from programming, but okay, this is a platform for programming and on the cloud. And in terms of infrastructure as a service, the most well-known is Amazon. You know, Amazon is not only the biggest online library, they are working a lot in terms of cloud services. And I don't know if you know this word, Internet of Services, is the new generation perspective of Internet. Now I'm working cost action, European cost action, is actually working on Internet of Services. So in terms of characteristics of cloud and resource management, etc., so we can find here different possible projects on cloud. So open issues, problems regarding allocation of resources to virtual machines, elastic rescaling of virtual machines resources, installing or installation of new virtual machines to load balancing, and also virtual machines placement and live migration. These topics I'm sharing with you are problems that Portugal Telecom share with us, requesting help to work with them to solve these issues. So this is good because I usually say the following. The companies are in real world, so sometimes they know better than us, academic persons, what is needed to increase or solve several problems. And this kind of cooperation is very helpful also for us because we can receive real and important problems to help to solve. And this is good because we can integrate students on projects with the company, and sometimes when they finish the master or PhD, they continue working in that company. So for us it's also good for our students. These are also different topics or more topics that we can work on. So cloud management is also a big issue, such as, for instance, creation of mobile cloud computing applications. And also, I'm preparing a PhD work plan now regarding this topic, vehicular cloud computing. So the idea is use this approach based on cloud computing and put it over VDTN. So cloud computing over VDTN. There are also, regarding the sensor networks, this buzzword crowd sensing. So imagine that you have in a smart city thousands of sensors, so we will collect huge amount of data. You have scenarios of big data, of course, cloud computing can support it, and we have scenarios here of crowd sensing. So there are also an interesting hot topic that can be studied is personal intelligent assistants. So imagine that we are in the city and you ubiquitously receive information about the environment, about the transport, about the energy, about the weather, etc., including your own agenda, and you don't need to find information because information can come to you. Of course, we don't have to disturb the person, but each person can personalize the available solutions. So, in fact, we work quite a lot, but the life is not only for working, and in our group we have also interesting activities such as we have a football team. We play several times, we have several activities. This is a programming context promoted by Portugal Telecom that we participate regularly and different activities. So this is only a list of several publications that are consequent of the work that I already completed. So just finish. I will go further to the next presentation because the time flies. I don't know if you have any questions regarding my brief presentation of our work. If you allow me, I can continue. Yeah? So, this is the proposal that Valerie sent me. So, share with you something related with wireless sensor networks and their industrial applications. So, my idea is, I don't know your background on sensor networks. I will try to introduce the technology, highlight some main characteristics, and after share with you some applications, some projects, such as illustration of the application of wireless sensor networks. Okay? And I also would like that you not sleep. Okay, so in terms of outline, I will start introducing wireless sensor networks, some points regarding the main characteristics of wireless sensor networks in comparison with regular networks. I will try to list possible applications and utilization of this kind of tiny networks. Currently, you know that we would like to address all the objects. So we evolution of sensor networks with the convergence on all over IP. We have this new paradigm identified as Internet of Things. In Cisco, there are authors that also identify a new evolution of Internet of Things, such as Internet of Everything. So we can have, for instance, at home, we can have an IP in all our objects. Imagine the fridge, you can have an IP there, you can have an IP in your TV, you can have an IP in the doors, in this door, you can have an IP in air conditioner, etc. So you can easily, in a touch screen, put in the door of the fridge, you can control, for instance, all your home. In fact, there are already available solutions for that. I have a friend in France, University of Haute-Alsace, cooperating. In his home, he has this solution. So when we visited us in my university, in a presentation like this, he connected on real time his house and show us the temperature on each division of the house. We can put down the protection of sun, etc. So everything can be done automatically or through an action through a computer, because we can address each object and you can interact with them in real time. You can gather information, so you can have sensing, and we can also have some kind of action, so we can have actuation. So we can also have actuators on the system. So this is possible because you deploy IPv6 on each sensor. So 6LoWPAN, low power wireless personal area networks. So this approach I will show you is the possibility to deploy IPv6 in sensors, because as you know, IPv6 in terms of packet size is quite big. You cannot accommodate it on technology used on sensors. So there are such as a conversion, both sense, between the regular IPv6 and IPv6 deployed on sensors. So it is possible using, for instance, 6LoWPAN. So I try to identify new challenges and issues for sensor networks in terms of research issues. By the way, I prepared a new presentation, maybe for tomorrow, identifying possible research topics for wireless sensor networks. Share with you some contributions, some work that we already performed. So, talking about wireless sensor networks, a brief introduction. So we can identify wireless sensor networks as a subtype of low power wireless personal area network. So the devices can collect data for the environment, for our body, for instance, if you are using body sensor networks, and they can communicate among them, and these devices can cooperate for a common task. So this is really important, mainly for instance in industry. I'm very happy to know that your university is very active and has a close cooperation with the industry, and I think it's really important that we can contribute for that. These small objects are self-organizing, self-optimizing, and also fault-tolerant networks. So we also work on this sense, trying to turn these networks as much as possible close to the regular networks that you already know and you are using currently. So, in fact, we can have a wireless sensor network with thousands of sensors. Here is a figure where we illustrate, such as an example, a wireless sensor network. These are photos of sensors that we have at our lab. This is a telescope sensor. As you can see here, this part of the sensor is just for the power supplies, 2 power supplies, the small ones. And this is the sensor. This is a USB connection for programming and deploy the software on the device. You are using UDP as a transport protocol. You are using IPv6 over 6LoWPAN on the network layer. I don't know if you know the TCP/IP architecture, I believe yes. And at link layer, you are using the standard from IEEE 802.15.4. For instance, in wireless, you are using IEEE 802.11. So for wireless sensors, you are using this standard. So, as you can see here, we can have, for instance, a computer that can act such as a gateway among the TCP/IP network and the wireless sensor network. We are using a sensor just to deploy, to offer us this kind of communication over wireless, because as you know, in our computers you don't have 802.15.4, where only have wireless or Ethernet or Bluetooth, etc. So here, this device is not acting as a sensor, just as an airport to provide IEEE 802.15.4 to communicate with the sensors. And okay, a regular computer can be connected to the internet, so we can get data from the sensors and save on a web server, for instance, on a database, and you can access to this database and see the results. Of course, we also deployed works with providing end-to-end connectivity, and from the internet we can address a node and we can connect directly to a given node because it has an IPv6. Okay, so we can easily do this, and this is important to mention. In terms of network architecture, as I mentioned you, the standard 802.15.4 at MAC layer communicates directly with 6LoWPAN that appears such as an overlay layer between the link layer and the network layer. So this is possible because we have here is a combination layer called 6LoWPAN. Okay? So this is deployed, and here I explain why it is possible. I already mentioned you the problem regarding the packet size of IPv6 and regarding the small size of this kind of networks, because as you know, these sensors are power, they have power constraints, they are very limited in terms of processing, in terms of memory, etc. So we should optimize the capacity of the sensor nodes. So this is the explanation and the need of this 6LoWPAN layer on the architecture. In terms of trying to identify the main difference between wireless sensor networks and our regular networks, I mean TCP/IP networks, or if you prefer, internet networks, because internet is a kind of TCP/IP network, the biggest one. So, as I already mentioned, you have energy and resource constraint in terms of these tiny nodes. You also have small wireless transmission power and throughput in these nodes. As you can see, our computer spends the most part of energy with the communications, mainly with wireless. So of course, if you have these tiny nodes and you want to preserve energy as much as possible, we have several limitations. In terms of the types of links, in this kind of nodes, we don't have, or we have transitive links. This is a problem because imagine in a forest or in a house, we have concentration of thousands of nodes in several regions, so we will have problems regarding the equilibrium of the network. If we have mobile nodes, we also have this problem regarding the architecture of network and the structure regularly change. And it's mentioned here, the different kind of topology that change if we have mobile sensor networks. So here we are arriving to one of the points that it was proposed to me to identify. In fact, currently, we can use sensors in almost all the issues that we are working on. We can identify several sets. One of them is industrial applications and automation. We know very well that in industry, usually you have automata, you have lots of automation, and sensors can provide us easy way to control the different machine and device that you have inside an industry, for manufacture, for instance. It is important to mention that in the past and the previous versions, these automation solutions and also sensing solutions usually uses private technologies, not open technology, or doesn't use standards. And currently with the TCP/IP using IPv6 over 6 loop, and we can provide and use open architectures. So a very key topic currently, also European Union is funding big projects, is this topic related with smart cities and also urban networks. In Portugal we have 2 case studies. One of them is supported by Cisco and IBM, and the other is a research project. So we are working to create this new generation of urban environments based on technology. Also regarding the home and the houses automation and the intelligent houses. We have lots of possibilities in terms of environment monitoring, including precision agriculture. So in fact, we can use lots of environment sensors and also actuation on regarding, for instance, agriculture in terms of application to the agriculture. I think here in Russia we have a good opportunity regarding minerals and petrol exploration, etc., because we do produce this kind of products. Also regarding electricity, the use of sensors and we are using for this environment smart grids work. So in fact we can make an intelligent management of energy. And the sensors, I don't know if you know it, but the first sensor application was in the military environment. All of us know that the network's evolution and the origin of the internet, so it was in the military departments and also supported by military projects. With sensors, it happens the same. So in fact, it's easier to send sensors to the opposite side and collect information about them instead of having people there. And also regarding the environment, etc. And as I already mentioned you, in terms of health, e-health, mobile health, we can deploy lots of applications using sensing approaches. I don't know if you have an idea. You can easily find this information on the web. If you go to the Apple Store, Android Store, Windows Store, the applications for mobile devices, you can easily find the following information. applications for health and well-being are the applications with most success. Is billions of downloads of this kind of applications. If the owners sell these applications, imagine $1, for instance, you can't imagine multiplying by millions of downloads. You can imagine the success for the creators of this kind of applications. So, in fact, currently our smartphone is not only a mobile phone, it is a small computer that we can carry. The most recent devices carry different sensors, gyroscope, etc. So we can create lots of applications that can use the device that are embedded on mobile devices, and using Bluetooth can easily connect to body sensors, so we can create innovative solutions based on sensors applied to health domain. So these are the main topics regarding applications of sensors that we can have. Of course, you have this etc. because there are also new applications that we can identify in the future, and I didn't put here. So it's important to mention that we are working and we are talking about this new paradigm based on the evolution of the sensor networks and the networks convergence on IP. Currently, we are talking about all IP networks. I think you already heard about it. And this term, Internet of Things, is such as a new vision that is envisioned for the networks and embedded devices that are omnipresent in our day life. So as already mentioned you before, and they can provide us relevant information, content regardless location and time. So, in fact, the sensors and actuators will play a key role on this new vision. So, these devices will be able to exchange, to collect, to receive information from others. They can communicate among them, and they can be connected and available through the internet. So based on this, assuming that we are connecting these devices to the internet, and at the same time, of course, they are connected to the internet because each one can host an IP address. So in fact, it will offer an opportunity for internet growing, and we cannot imagine when the current IPv6 address will be full of end users. It is expected that they can live for several years, but we cannot measure how many years we'll have this IPv6. Of course, we have about 200 IP addresses for square meter of the Earth's surface, but we don't know when they can be all of them users. So, in order to achieve this Internet of Things vision, as I already mentioned, is needed to incorporate IPv6 on all the objects. And of course, if we use open architectures based on IPv6, we can connect all of the objects among them. And of course, we can simplify the heterogeneity of the network, because all the network is based on IPv6 following TCP/IP architecture. That, as you know, of course, follows OSI theoretical model from the International Standards Organization. So all of them are based on open architectures for interoperability and so on. It's very, very easy to use. In terms of connectivity models, on these approaches, on this vision based on Internet of Things, mainly you can have two different approaches. One of them is the most traditional. Imagine we can have devices, computers, mobile devices, you wish, connect to a proxy servers, and this proxy offers access to the mobile nodes. These nodes are sensors, we have routers to provide access, and of course, through the internet, we only can connect to this proxy, and the proxy provides us the access to a given node. Following the end-to-end connectivity model that we believe that is much easier to handle and also to deploy, we can have end-to-end connectivity, and instead of having a proxy server, we'll have routers that can interact with IEEE 802.15.4, and in this side we have the regular internet connectivity. So instead of having proxy server that is a constraint between, such as a bridge between the two kind of networks, here we can involve all of them and we can easily integrate sensors on the internet based on this approach. This is possible because you have 6LoWPAN, so now I have some considerations about 6LoWPAN. So, as I already mentioned, is a way to deploy IPv6 on this given sensor. This is, I repeat the layered architecture so as to illustrate. And in terms of characteristics, so 6LoWPAN enables transmission of IPv6 datagrams, the IPv6 packets over standard IEEE 802.15.4. It uses either compression, as I mentioned regarding the size of the packet, because in IEEE 802.15.4 you have small size packets. Of course, it will handle the packet fragmentation because a given IPv6 packet is very big, so it should be split in small fragments to be handled and carried by this link layer. And of course, we provide link to forward at the IEEE 802.15.4. In fact, this kind of networks, we can divide the challenges of these kind of networks in two main groups. One of them is in the client side, in the perspective of usage, is the perspective of new applications, new service that we can create, you can provide based on wireless sensor networks and that way. The other is based on the network. So in terms of Internet of Things, there are several topics that can be addressed and studied or deeply studied. So one of them, and more traditional, where we can find a huge amount of available papers in the literature, is the energy saving solutions to save energy, because I don't know if you have an idea. For instance, if we deploy thousands of sensors in a forest, for instance, for fire monitoring, environment monitoring, etc., usually each sensor with this application will die when the power supply exits its life. So it's important to have solutions, because we know that these kind of sensors, after consuming all the available energy, simply will die, then they will be lost. So, because they are so cheap. There are other issues regarding the self-organization of nodes. We can also have this topic related with neighborhood discovery, because imagine, for instance, that we have in a network lots of sensors and there are two nodes communicating among them. If one of them died, the other should found in the boundary a new node to connect. So here you have, in terms of self-organization and network discovery, lots of problems that can be addressed. The typical problem of network discovery is the following. Imagine that we switch on a new sensor, we put in the network, how it will be connected autonomously, automatically to the available network. So service discovery, IP address assignment, and so on. So the easy way that we have now with DHCP and plug-and-play issues in regular networks that are not available commonly in sensor networks. So here there are several problems that can be addressed. Another problem regarding the network topology changing, these characteristics of the network. We have lots of problems regarding network management, and we already performed several work on this issue. We already deployed SNMP, the standard Sample Network Management Protocol, on sensor networks and perform experiments. Also is the service announcement and service discovery. So we have a new sensor on the network. What it provides is a temperature sensor, is an accelerometer, is a gyroscope, is a small tiny video camera. So what kind of services this new sensor can provide, how can we connect to it and extract the information that it can provide. So this is a topic that can be addressed in this big issue. And another is the problem related with routing protocols. In fact, 2 years ago, the Internet Engineering Task Force provided a new standard for routing protocols for wireless sensor network, is the Ripple. I don't know if you already hear this protocol. It is headed to Internet Protocol for wireless sensor networks and deploy new services and new routing approaches on this kind of networks. In fact, we were very sad when this new protocol appeared, because one of the excellent PhDs that I have, he was working exactly on this problem. And when this new protocol were proposed, more or less his problem was solved by others. And we needed to adjust his PhD program regarding the focus of the main focus of the research problem that he has in hands. And in fact, this is something that can happen while researching. So we identify a research problem, and all the people can work on the same problem, and sometimes it is solved, and our problem is not anymore a problem to be addressed. So we need to change or adjust a little bit to work better. So, given this big picture about different challenges and issues that can be considered on wireless sensor networks, I will share with you several works that we performed regarding this topic on wireless sensor networks. So, we create several test beds in our lab because we have different sensor technologies. We have about 7 different types of sensors that addresses different challenges, and they created a gateway for 6LoWPAN, this one that I already mentioned before. So, as I already also mentioned before, we already deployed SNMP V1, first version, because it's the most easy to use on wireless sensor networks, and this is an issue that can be further studied. Create web-based solutions to monitor wireless sensor networks, and also trying to have calculation, so in the other side, communication. Real-time and distributed wireless sensor network was the key topic of my former PhD student. He's from Senegal and worked on this topic, very nice person. And here you have a network access control framework for sensor networks. This is the result of the adjustment of the PhD work that I already mentioned you. So the main focus of the PhD work was on routing protocols for wireless sensor networks. And given the problem was already solved, we changed a little bit and we created these solutions, trying to propose solutions regarding network access control, addressing security issues on wireless sensor networks. This is a project that we helped to solve a problem identified in a PhD in medicine. There are a young medical doctor that is pursuing a PhD. He is studying the behavior of our body when you are going up in these small aircrafts. There are no pressure in the cabin. So we created a solution to study this problem, mainly in terms of oxygen in our brain. So I will show you later some pictures about it. Cloud sensing, and also scenarios with thousands of sensors. How can we handle the information that is being collected at the same time? You have lots of problems that can be addressed. And also, this is an important problem for ELC issues, is mobility support for real-time communication using wireless sensor networks. So imagine the scenario. We have patients that must be monitoring on real time. But if you don't provide this kind of solution, the person should be with limited movements. Imagine you must be inside a room only. So with this kind of solution, people can move freely. This kind of approach is already available for mobile networks, but it was not available on sensor networks, so we worked on this. This is the main topic of PhD that I supervised and finished last April. So I will share with you some slides about this contribution. So the 6LoWPAN contribution this is the scheme. So you can see the architecture of the gateway. As you can see here, in one side we support TCP/IP regular network, and the other side, so here we have the interface with the sensor network supporting 6LoWPAN and based on IEEE 02, and here we have the sensor network. In the other side, we have the internet connectivity supporting IP. This is the embedded that we create. It's very easy. So here is the power supply. This is the main plug. This is the hard disk, the flash disk. Here is the airport connection for where is it? The Ethernet port, and in the other side we have it's not here. Maybe it's connected here. I don't know. We have the IEEE 2.2.15.4 airport connectivity. So we performed several experiments using different kind of nodes. Here you can see different kind of sensor nodes. This is MicaZ nodes. This is IRIS nodes. And in the previous figure, when I showed you this illustration of sensor network, we are using TELUS-V. This is the gateway, and this is the client. So imagine this computer connects to the internet and goes tries to communicate with these sensors. Here we also try to demonstrate that you can use different hardware, because as you know, maybe I don't know if you know, commonly different manufacturer of sensors and also different timing devices are not compatible among them in terms of communication, because they use different technologies. If we use 6LoWPAN, we are using an open technology, so we can provide here an environment for heterogeneity in terms of nodes. This is something that is completely common in microinformatics. You have Linux, you have Windows, you have Apple, and all of them communicate without problems. So this, in fact, is a problem, more or less a problem in wireless sensor networks, then is a topic for research work. So here is also with more sensors, as you can see, different sensors. So the idea is trying to offer a gateway that can interact with different operating systems. I don't know if you know, TinyOS is one type of operating system created in Berkeley, the University of Berkeley, for sensor nodes, and Config operating system is an operating system proposed in Sweden by Adam Dunkels, the leader of the research group in Sweden. He's a young guy with my age, and he's proposing a very strong contribution for the community in terms of operating system for mobile devices. So in terms of management systems for IPv6 enabled wireless sensor network, this is the network architecture, and just to highlight, we are using SNMP, this is the application, we are using SNMP, the standard for network management, and we adapted it for sensor networks. So in fact, when this protocol, the standard protocol, was proposed, it was for the regular networks. It's quite heavy for sensor networks, so we adapted it. We had such as a light version of SNMP version 1 and applied it to sensor network. What is the idea here? Imagine that you have a network management solution. We can also manage sensor nodes through the available network management solution that we can have in a given network, such as inside the university, for instance. So here you have several, so here you can see what's happening in real time. So we have such as a console where you can see what's happening in the server, and here are several characteristics of the created solution. In this project, we created a web-based solution to interact with sensor nodes. So here we have information about each sensor you can have here, for instance, the date of the last extracted date, and the idea is have a single database, a single web-based solution, and collecting data from different wireless sensor networks. We can save data from different networks in the same database, and at the same time we can interact with different solutions. We also created the mobile version of this solution. So here you can see the mobile application, so authentication. We can identify here different networks, and after choosing a given network, we can arrive to a node. And for instance, we found a node identified as such as node 2. We can see an instantaneous data, in this case temperature, and you can see here the evolution of the historical data of this sensor. So this is a small example of this application. As I already mentioned you before, FlySafe is the name that we call the project. The idea is the creation of a wireless sensor network solution for light aircraft pilot monitoring. So here you can see several research papers from medicine identifying the problem. So the problem of hypoxia, and also the oximetry, and the problem is this: altitude physiology and the stress of the flight. In small aircrafts there with the cabin is not pressurized. So given this is a problem that this young medical doctor is studying in his PhD, because he's also for hobbies pilot, and they requested us to find a solution to study this problem. So we created the technology solution, and after they continue using it for the study the medical problem. So the main goal of this project is create a solution based on standard protocol to monitor the aircraft environment and at the same time the pilot's physiology parameters. So what we did, we create a solution based on body sensors and environment sensors, and we also create a prototype, of course, and use it in a real environment. So in terms of the approach that we created using standard technologies. We use the GPS for the position and also measure the altitude, temperature inside and outside the cabin, and also the temperature of the person, the humidity inside and outside the aircraft, a 3D accelerometer to measure the positions, and because there are no other means to extract data for cerebral peripheral oximetry saturation, so the equipment that has been provided to us only offers Bluetooth communication, so integrated it, and we created this prototype that was demonstrated using an aircraft, and we also performed several flights. I put this information here because the next figures are from the experiments that we did in this approach. So this is the photo. You cannot see very well, but this is the equipment for the peripheral oximetry, and it communicates with the computer through Bluetooth. This is the sensors, the transducers that can be placed in the head. These are the different sensors, and is the small computer that we use it where we deploy the created application and store data, etc., etc. So in terms of sensors, we use the 3-IR sensor with the MTS expansion board to measure air and body temperature, humidity, atmospheric pressure, and an accelerometer. You use this technology on sensors over IPv6, and this non-new equipment for the oximetry brain measure. So this photos of the experiment. So this is the supervisor of the medical doctor, and this is my PhD student that deployed the solution with me. And these figures show us the solution inside the aircraft, so the computer, there are different hardware that we deploy to measure data. Here is a photo showing the installation of the equipment in the person, and this is the preparation for flights, and this is a figure when we made some experiments. So it was a really nice project, and the result was good, and it's already published. So this is also answer to a problem that a medical doctor asked to us. So this is a professor of gynecology that studies several kinds of cancers, and also new or innovative methods to increase fecundity, and also the opposite, to avoid it. And the medical doctors knows that depending the hour of the day, and our temperature change. So it's the biology cycle on each day. The females has a particularity of this period. So the idea is to create a tiny solution to make studies to identify the evolution of the temperature along the months and along the day, in order to identify what can be the best hour of the day to evaluate and to apply several pills. So this is another sensor technology, Shimmer, we created in Ireland.